Okay, so far we've talked about the probability of a single event. But what if you wanted to calculate the probability of a single event occurring multiple times? So how does one deal with an n number of successes of a single event? So let's kind of learn about this through an example. So as you can see, I really like using a six-sided die as an example. So our question is, what is the probability of getting a certain number of sixes on a six-sided die? So we'll let event A be the event of rolling a six, and our sample space is the outcomes of the elementary outcomes of a six-sided die. So, um, so if we were to roll the dice once and get one six, this would be the probability of getting one six, the probability of A. But what if we rolled the dice twice? We performed two trials. Then we'd want to know what's the probability of getting two sixes. And so the probability of getting two sixes is the probability of getting a six and a six. And the probability of getting two sixes would be the probability of one six times the probability of getting a second six. And anytime you've got two things that are being multiplied, that's equal to that number raised to a power. So we can take the probability of A times the probability of A and write that as the probability of A squared. And so now if we were to roll the dice three times and we wanted to know the probability of getting three sixes, then that's the probability of getting a six and a six and a six, which would be the probability of A times the probability of A times the probability of A. And since there's three of them, it's probability of A to the third power. And if we were to roll the dice four times and find the probability of getting four sixes in a row, it's a probability of six and a six and a six and a six. Or the probability of getting a six once, but multiplying it four times, which would then be the probability of getting a six to the fourth power. So hopefully you're starting to see a pattern. When we calculated the probability of getting just one six, that was actually raised to the first power. So the probability of getting one six was to the first power. The probability of getting two sixes was to the second power, three sixes, the third power, four sixes, the fourth power. And if we were to roll the dice 10 times and we wanted the probability of 10 sixes in a row, that'd be the probability of getting a single six to the 10th power. So hopefully here what you can see is that whatever value n is, that's what you're going to use as the exponent to the probability of that single event. So back to our original question is, what's the probability of getting a certain number of sixes? Well, let's say we were going to roll the dice three times, and we wanted to know what's the probability of getting three sixes with three die rolls. Well, that would be the probability of getting a six to the third power. And so the probability of getting a six, that's going to be the order of A over the order of S to the third power. So that's going to be 1/6 to the third power, and that comes out to 1 over 216, which is a little under 0.5%. So the probability of getting three sixes in three die rolls is less than 0.5%, 0.463%. So use this example as a model. Come down here and look at this think, pair, share. Give this one a try. So go ahead and pause the video and come back when you're ready. All right, so let's look at this think, pair, share. Now what's different a little bit about this one is we're looking at a six-sided die, but this six-sided die comes from a particular board game where they've made a custom die. Okay. So a special six-sided die for a board game has the sample space of 0, 1, and 2. So this doesn't have 4, 5, or 6 pips. It's only got no pips, 1 pip, or 2 pip. So that's kind of what you see here in the picture. This is the front side of the die, and then this other picture is the back side and the bottom of the die, just to kind of show you that it's only got 0, 1, or 2 pips. And the probability of getting a 0, a 1, or a 2 is going to be 1/3 for each of these. So the first question is, what is the probability of rolling 3 zeros in 3 die rolls? So our event is going to be getting a 0. And so what's the probability of getting a 0 with 3 die rolls? Well, the probability of getting a 0, oops, let's do this. The probability of getting a 0 is 1/3. So that's going to be 1/3 to the third power, which is 1 over 1 to the third over 3 to the third, which is going to be 1 over 27. And, if we use our calculator, let's do this. We've got 1 divided by 27. So that comes out to 0.037 and some change. So the probability of getting 3 zeros in 3 die rolls is going to be 3.7% approximately. Now, the second question is, if the consequence of rolling 3 zeros in 3 die rolls were dire, meaning if you got 3 zeros in 3 die rolls, if that was severely bad in this board game, and anything else was beneficial or of small consequence, would you take the risk? So if the risk was only 3.7% of something really bad happening, would you take that chance and roll the 3 dice? So here for answer 2, I put a YouTube video, and if you start it at 7 minutes in and you watch it for a full minute, you can kind of see an example of this probability play out in an actual board game. All right. Let me know if you have any questions.